Alright, in this video we're going to talk about and practice some neutralization reactions of acids plus bases. So this first one here, I have hydrochloric acid and sodium hydroxide. They're going to react together to neutralize, and like all neutralization reactions, it's going to make water plus a salt. Now in this case here, it's going to be salt itself, sodium chloride. So I have the sodium cation here and the chlorine anion there. So neutralization, water plus a salt. All neutralization reactions will have that. Next up, I have nitric acid, HNO3 plus lithium hydroxide. Well, it's a neutralization reaction, so the first thing I'm going to write is water, because they're all going to be making that. Now I'm going to be combining this. It's like a double displacement. The lithium cation is going to be combining with the nitrate anion. Lithium has a charge of +1, nitrate has a charge of -1, so it's just going to be lithium nitrate. Next up, I have carbonic acid, H2CO3 plus potassium hydroxide. Well, it's a neutralization, so water's going to be the first thing. Now I have the carbonate anion, which is going to be a -2 charge, and then I have the potassium, which is going to be a +1. So my end result is going to be KCO3, but of course potassium has a charge of +1 and carbonate is -2. I have to use the crisscross method, and now I get K2CO3. So you'll notice that now I need to balance it out. Since I have a 2 there as a subscript, I need a 2 for my coefficient in front of potassium hydroxide, and then of course to balance that out, I'm going to have a 2 in front of the water. What you should also notice here is that I have a 2, it's a diprotic acid. So a diprotic acid is going to yield 2 water molecules. So 2 down there is going to yield 2 up there. Diprotic acids, at least 2 water molecules depending upon the equation. Now I have phosphoric acid, H3OPO4, plus sodium hydroxide. Of course, it's going to be a neutralization, so I have water, but we know that the phosphate anion is a -3 charge, and the sodium cation is going to be a +1 charge. So I'm going to work that out, NaPO4, but it's going to have to be 3 to account for the fact that it's a -3 charge there. To balance that out, I'm going to need 3 in front of the sodium hydroxide. That, of course, is going to give me 3 water. So here I have a triprotic acid is going to give me 3 water molecules. So here I have acetic acid plus barium hydroxide. That is going to react together to form a neutralization. So water, of course, is going to be created, and I need to look at my acetate as a charge of -1, and barium has a charge of +2. So I'm going to combine those together in double displacement, barium acetate, but of course I need to account for the fact that barium is a +2 charge and acetate is -1 using the crisscross method. That's going to be Ba and then 2 of the acetate anions there. Then to balance it out, I need 2 right here and 2 right there. That is going to give me a balanced reaction for this neutralization. All right, phosphoric acid plus magnesium hydroxide, neutralization. So I'm going to have water plus phosphate is a -2 charge, magnesium is +2. So I'm going to combine those with the double displacement, but I need to use crisscross to figure it out. So it's Mg3PO42. Now to balance it out, I put a 2 for the coefficient there and a 3 for the coefficient there, and it sits right here, balancing everything out, left side and right side. Now it is balanced and completely neutralized. Beryllium hydroxide plus H2SO3. So that's going to be my acid right there, neutralizing. So I have water. The sulfite anion is going to have a -2 charge, and hydroxide is going to be -1 right there to account for the fact that beryllium is +2. So when I combine it, that's going to be beryllium sulfite, and then of course I don't need to use any sort of subscripts down there to balance it out because this is +2 and that's -2. But I do need to account for the fact that this is a diprotic acid with 2 water molecules right there being created. All right, I have ammonium hydroxide plus I have H2C2O4. So that's going to be our oxalate. So that's oxalic acid. So I have my ammonium hydroxide +1 and -1 charge there. The oxalate is going to be a -2. So of course it's neutralizing. I have water, and then I need to combine. It's going to be ammonium combined with the oxalate one there. Oxalate is going to be a -2. Ammonium is +1, so I'm going to have 2. So it's NH4 2C2O4. All right, HBr plus rubidium hydroxide, so hydrobromic acid plus rubidium hydroxide. Simple double displacement, don't need to do any balancing there. So I'm left with water plus rubidium bromide, which if you kind of look at it, it's a palindrome. The more you know.